Hello and welcome to the final lecture on vaults. I'm here with my colleague Sigrid Adriansen.
And we're at the Maritime Museum in Amsterdam.
Sigrid, I'm so excited to have you here with me to deliver this lecture. Sigrid is a professor at Princeton University and a close colleague of mine. She has also designed contemporary vaults. In particular, she worked on a team of the vault that we are standing under right now, the Dutch Maritime Museum. We will talk about this gorgeous vault towards the end of the lecture and keep everyone in suspense. Is that okay?
Sounds good.
This lecture is unlike other lectures since it does not focus on a person or a culture. Instead, the lecture focuses on vault designs of the new millennium, and it has evolved since the times of Tedesko, Nervi, Guastavino, Torroja, Candela, and Isler. We will discuss what has caused this evolution, and the answer is in the title of the lecture, New Tools and New Materials, which have enabled new forms. Sigrid, why don't you tell us about the specific lecture goals that we have?
Okay, so we're going to be looking at what are the new tools and what are the new materials available to engineers. And we're going to focus on two contemporary vaults in mixed steel and glass shells. We're going to look at the Berlin Central Station and the Dutch Maritime Museum. And you're also going to learn how to use graphic statics to analyze arches.
And then we're going to end today's lecture with the Art of Structural Engineering Vaults, a summary of the entire course. Before we move forward with contemporary vaults, I'm going to review for you what we have studied so far. We started with the Germans, where the forms were domes and barrels, and the approximate years that they were designing were 1920 to 1950. The innovations of the Germans were the equations. They developed the membrane theory for domes and barrels. We also looked at Pier Luigi Nervi in Italy, and his forms were domes, barrels, and cantilevers. He was designing around the 1930s to the 1970s, and his innovation was a construction technique which we referred to as the Nervi system, which involved precast concrete and also ferrocement. Then we looked at the Spanish culture. Their forms were also domes and barrels and cantilevers, and they were designing approximately from 1880 to 1940, considering the Guastavinos who were doing tile vaulting back in the 1880s. Their innovation was also a construction technique. Félix Candela, his form was the hyperbolic paraboloid, abbreviated HYPAR, and he was designing around 1950 to 1970, and his innovation was using straight line wooden forms for construction. And finally, the last lecture we studied was Heinz Isler, and his forms were of hanging forms, and his approximate years were 1950 to 1980, and his innovation was a physical form-finding technique. In all cases, the material was reinforced concrete, with a few tile structures from Guastavino and Gaudí. The tools that they used, it was the slide rule. I don't know if you're all familiar what a slide rule is, but it was before the calculator. In the 1970s, maybe a calculator was used as a tool. There were no computers used by these innovators, these structural artists that I just spoke of. With the advent of the computer, one might imagine that designing these vaults would become simpler, and therefore more vaulted structures would be built. But in fact, the opposite is true. Starting around 1970, one observes a steep decline in reinforced concrete vaulted construction. Sigrid, maybe you could tell us a little bit why that is.
Sure. In 2005, a study explored possible reasons for this lack of thin shells or vaulted concrete structures after about 1970. In their survey of practicing engineers in the United States, they highlighted three primary responses to the question of why thin shell concrete structures were no longer being built. The first reason was that there was a belief that they cost too much to build. The second reason was that they had simply fallen out of favor with architects. And finally, there was a perception of difficulty in terms of the design and their analysis.
But this study was done in the United States, and we have seen how culture influences vault design for economical reasons and in aesthetic expression. In other countries, the responses to the survey might have been different. For example, in India, reinforced concrete structures are still being built. In particular, the designs of Mr. Sundaram deserve some special attention. Mr. Sundaram has been designing vaults or shells in India since the early 1960s. He's the founder of one of the largest architectural and engineering consultancy firms in India based in Bangalore. His vaults are all of reinforced concrete. I had the opportunity to informally interview him at a conference that I attended in Bangalore. Using a tourist camera, I asked him about his designs, his inspirations for his designs, and his successes. Let's listen. Thin shell concrete structures, it isn't built very much anymore around the world, but you have been very successful and you're continuing to build more thin shell concrete structures. So how is it that you are so successful in building these thin shell concrete structures here in India, whereas most of the world, this kind of construction isn't happening?
In India, I think people think it's very difficult to design shells. So the designer, they don't go near the shell structures. And whenever there's an opportunity, I propose a shell structure to the client. Luckily, my clients are all very knowledgeable and they understand that we will deliver a good system to them. That is how. Other thing is, cost of construction of shell is little lower here than any other part of the world because of the predominantly cheap labor here.
In studying your projects, I see an evolution of your works. I've seen a maturity going from the 1960s to the 1970s all the way through today. And what we refer to that is the evolution that a structural designer goes through called imitation, innovation, inspiration. So what I saw is you start imitating traditional shell forms, and then I saw some innovation in there which led to what we call inspiration, and this alliteration is what David Billington refers to as the evolution of the structural artist, where inspiration are your greatest works. Do you see that evolution in yourself as well?
Absolutely. Initially, when we want to do shell structure, our idea was just to span it and make it safe. We didn't think about aesthetics too much at that time. For example, we did a lot of knot-like shells, cylindrical shells, folder plates, simply spanning it, and we were really happy that it could span, no cracks, no problems like that. Later on, slowly we evolved that we should give attention to aesthetics also. Then we went to the hyperform. You see, I still remember Professor Ram, University of Stuttgart, he made a presentation in Toronto. What is the ideal shape of a structure? He arrived very close to the hyperbolic paraboloid. So we are now doing more of hyperbolic paraboloid with a lot of sense of aesthetics, avoiding beams, expression, the smooth curves, and make it also economical by trying to repeat the form work.
Speaking of the hyperbolic paraboloid, I went to visit the food court at the Infosys campus, which are hyperbolic paraboloids. And I haven't seen, but I've seen images of the Miko Bosch food court as well, which have umbrella forms. This reminds me a lot of Félix Candela. Did Félix Candela inspire you in any way in your designs?
He is one whom I wanted to follow, but my favorite guy was Nervi. So because Nervi did a lot of excellent work. Not only he went for large span shell structure, but also made it very aesthetically very pleasing.
Speaking of Nervi, one of the structures that reminds me a little bit of Nervi is the Cantariva Indoor Stadium.
Right.
Did Nervi inspire you for that stadium?
Absolutely, because I've seen when I was a student at MIT, we did an analysis of Nervi's work, a similar studio, and then we found it is safe. That was the conclusion at MIT. A professor directed us to do an analysis. We did a theoretical analysis, found out Nervi's structure, that structure is beautiful structure, is safe and sound.
Well, thank you very much for your time. This was wonderful. Thank you.
Thank you. Thank you.
Although Mr. Sundaram has been and continues to be successful in designing reinforced concrete vaults in India, as I mentioned earlier, in other parts of the world, these types of vaults are no longer as common as they were in the mid-20th century. But vaults do continue to be built, correct, Sigrid?
Yeah, but just not always in the same way as they used to be built in the 20th century. So we now have new tools, new materials that enable new forms for vaults. Let's now examine these tools and these materials.